Hello YouTube, this is Alexander again, and today is kind of repair day because I have on the bench this little PCB, and this little PCB comes from a hood coming from a restaurant, and the owner made a big mistake. He connected this PCB to high voltage, not the main. The main is 230 volts, and he connected this device to 400 volts. It creates some damage on the PCB, and of course he changed the fuse because the first thing who was blown was the fuse, and he made another fuse more stronger than the first fuse who was here. And of course what happened in that is there is a component destroyed on the PCB. If you can see here, you can see here a missing component. This missing component is called RV3. RV like varistor, something like that. Okay. If you are not sure, we can see on the PCB for some hints, and we can see that there is here some another component which are called RV1 and RV2, and logically the missing component is RV3, and we have to guess that those components missing, this component missing, is just a varistor for protecting the PCB from high surge of current, which are not desired in this kind of configuration, because this is a PCB for a hood destined for working with the main. If you can see here on the little classical transformer, you can see that is working for 230 volts, not for 400 volts. This is a mistake of the owner of this PCB. And so because he tried to make another fuse, there was now more damage, as this little component missing who was completely destroyed and disappearing from the PCB. You can see here some missing track because of the copper. If you can see, the copper of this little track, according to the neutral and the live, are evaporated. You can see this is evaporated copper, and definitively this device is not able to work now. So because there was electrical shock on it, we have to test on this PCB if another component was damaged by this surge of current. Of course, if this move did his job, you don't have to fear about some damaged component. But logically, the first component who was in trouble is the transformer, and also the triac, and maybe the component on the secondary. But we just have to test it. But I think there is not a big problem on it. So here on the other side we have no hint of black marks, and in ohm meter we can check the primary, which is quite good, and the secondary. We have here two secondary, and they are in series connected. One is more bigger than another because we have not the same value for each, and here we can see they are connected in serial. So we can see there is some diode on it, and to check the diode to see if there was shocked by the surge of voltage, we can see here something charging, which is not very important, but here we can see a threshold voltage, which are nice, also threshold voltage, and we can see here some protecting diode for the relay. This diode protects the circuit from the current coming from the switch on-off about the coil of this relay. So to be very simple, we can just try this diode to see if they are good or not. And to confirm about the missing copper here, we can test on test mode if there is again little copper on it, but of course they are completely missing. So firstly, we need to change the fuse holder and replace, found another more MOV like this one and replace it on the missing place here. We can also try if the optotriac here is still alive or not. So always in diode mode we can try one side, and as you can see this pin is not connected, so we need to make some measurement on this one and this one. This one is not connected, so if all is fine we need to find what happened here. Okay, we have here the positive. Okay, that's good. Okay, this is the threshold voltage of the diode inside. Okay, this is the diode who commands the optotriac in the other side. Okay, there is absolutely no reason to find this command damaged. Okay, just try about the triac if something is bad. We can guess that it can have a short circuit if something is wrong, but I also have a triac tester to be sure. So apparently there is not too much problem coming from this little surge. We have here this little transistor. Okay. Okay. Okay, it seems fine. So, okay, now we have to change this fuse holder and find another component like this. Fortunately, I have some components on this PCB. I can just remove this one and make the solder on it. Let's do it. Tin is not a bad idea, I think, but okay. Okay, here it is. And this one is exactly 275. Exactly the same. Now, let's change this one. The distance between the plot are not the same. I just wonder how I can figure to make it compatible. Okay, let's dismount it and see if, later. Okay. Let's try to repair those tracks. We don't want trace of flux here because this flux is very powerful but quite dangerous. You absolutely need to clean it very well. Okay. So the fuse was replaced, the mold was replaced, the broken track was repaired. What I want to test is the track. Okay, this track worked very fine. Okay. Okay. Now just try to make a measurement on this capacitor. Okay. Seems to be near perfect. Okay. Let's measure those relay. That's nice. That's nice. And those contacts are normally open. No. Okay. Those relay seems to be normally closed. Okay, those relay seems to have two contacts. You have here the coil and the NC and NO. NC and NO. Okay, all is fine. Okay, it remains to send it back to the client of this PCB. Okay, thank you for watching. It was Alexander again. See you soon.